Alright, so we're going to graph this using multiplicity of roots. F of x equals x to the fifth minus 8x cubed plus 16x. Of course, first we must figure out if we can factor anything out, and yeah, we can. We can factor out an x. That leaves me with x to the fourth minus 8x squared plus 16. Now what you have to realize is that inside the parentheses we have a perfect square trinomial. And this ends up being x squared minus 4 parentheses squared, which inside the parentheses now, inside this parentheses, we have difference of squares. So we're going to break that up even more to x plus 2 and x minus 2. And all of that is still inside the squared parentheses, the parentheses squared. So by property of exponents, each of the individual exponents will now get a square. So now we have the factored polynomial, and now we can use multiplicity of roots to graph this. Alright, so now we're going to, of course, list the degree. And the degree is 5, because 2 plus 1 is 5. The y-intercept is 0. Because when I let x be 0, when I let this x be 0, then the whole thing turns 0. That doesn't happen every time, but in this problem it does. And the x-intercepts, and that's the beauty behind this, is that the x-intercepts are right there. I have 0, negative 2, and 2. Now, let's list their multiplicity. 0's got a multiplicity of 1, negative 2 has a multiplicity of 2, and 2 has a multiplicity of 2. So we know that we're going to be going through the x-axis at 0. We're just going to touch and go at negative 2 and touch and go at 2. They have even multiplicities. You don't even cross the x-axis there. Okay, now let's graph this. So using all of that information, we are now going to graph. We know the zeros are at 0, at positive 2, and at negative 2. We also know that the degree is 5 and the leading coefficient is positive. So therefore the graph, the right end is up. The right is up and the left is down. Because my degree is odd and my leading coefficient is positive. So the right is up, then the left is down. So that means I need to come to my first 0 from a down position. So I'm going to come up to this 2. And how far do we go down? Well, I just found the midpoint of my zeros and put that into the function. And it turns out that f of negative 1, that's equal to 9. And negative 9, excuse me. And f of 1 is equal to 9. So 2, 3, 4, 5, 6, 7, 8, 9. That point's going to come about right to there. Doesn't even cross the x-axis. And it's going to go through this 0 all the way up to 9. 2, 3, 4, 5, 6, 7, 8, 9. 1, 9. See, I just found the midpoint of between my zeros. And it's going to turn, and it's not even going to cross the x-axis, and it's going to go like that. And it's a very interesting looking graph. What you should do is also verify that this is indeed the shape of the graph by using a graphic calculator.